talk about our Western Water Program. NASA has a water resources applied research program. Within that is the NASA Western Water Applications Office, and so I'm going to talk how that all is connected. I'm going to first step back a bit and let's see if I can move the slides here and talk about where we fit in the scheme of things with NASA. NASA Earth Science, just to give you a big picture. We're all about measuring to get a better understanding of the Earth as a system. So if you went to Congress and said, what's NASA's Earth Science mission? That is it. And then ultimately delivering to societal benefit. However, that nuance of measuring, understanding, and then actually turning that into information that is useful to guys like you and guys and gals like you is a challenge. It isn't straightforward, and it's something that the science community doesn't necessarily do really well, and that's our challenge. And one of the things I also wanted to mention that one of the reasons we do this is that we're looking a lot at bases. So we may measure some precipitation, but we're really interested in the interaction between precipitation and surface water and groundwater, and then ultimately maybe even water quality. So understanding those interactions is biggest challenge that we have, and that's what we're really focused on. That's why we do this. And how we're organized is we have the mission box, which is the big box, big in money. It also gets a lot of attention because we put these on rockets and we shoot them into outer space, and so they get a lot of attention. There's a technology component that really helps us enhance the technology. Like right now, I know Tim and USGS and NASA are working together on the future technologies of NASA or of Landsat. And so there's a technology portion of our portfolio. There's a basic research, like I talked about, that whole Earth system. And then we look at and try to understand how can we use this information to make decisions right now. And so that's how we're organized. And that leads us to how about information about water? So information from NASA Earth observing satellites. These are just charts, and I hope we can get these charts to you. I'm assuming we can share these at some point with everybody online. And largely for our purposes for water, we're focused on precipitation, soil moisture, groundwater, snow cover. And here's some of the observations we get from them. We're really good at precip. We've been doing it for decades. Snow cover, been doing it for a while. We teamed with NOAA on that. And of course, we've now had some nice soil moisture observations. Groundwater measurements from space is a new thing and evolving. Certainly one of the big challenges that we have. And we'll talk about that in some of our projects. And of course, there's surface water, where there isn't, and we can even get to surface flow, hopefully, at some point with our altimeter data from SWAT and others. Water quality, we'll talk about a project that's really moving water quality from really an oceans-focused system that we've had over the years. We're now able to take that technology inland, and more on agriculture water reuse, which is largely evapotranspiration measurements. Those are getting better. We're getting more of them, whether it's through Landsat, whether it's through our VIIRS systems, and now hopefully EcoStress and a follow-on mission that we're actually talking about as we speak. We also give access to this data. Now, this is both, I'm supposed to impress you with all this information, all these data centers and all this data and information, but I'm also embarrassed by it. Embarrassed in a way that we realize how difficult it is for users to access our data. Look, we have soil moisture data coming out of our out of our Colorado DAC. We have all this great information coming out of our South Dakota Aeros Data Center DAC. And then we have groundwater going from California and actually gets modeled in Maryland. So I hope you see this as there's a lot of data. It's all publicly accessible. It's great data, but we understand we have work to do to get better and easier access. This was designed for research and researchers, and the new DAC, the new generation of DAC will look a lot different. It'll be in the cloud. It's going to be have a lot more interface and hopefully a lot better utility to you. But it is one of the things we work on the interface. Now let's get to the NASA's Western Water Applications site. I actually was just on and we've had a number of conversations in NASA, and I was just on one right before this meeting about what is it that really distinguishes a basic research, lab coat research type of project that NASA works on and one with applied research. And it really is that interface, and you'll see those cogs that spin around, that persistent relationship that USGS has, that a lot of the other water management agencies have that NASA doesn't. And we recognize that. And so nearly 5 years ago, we started with this idea of a Western Water Applications Office, and it's taken some time. Understanding that NASA isn't structured like a cabinet agency that provides a statutory water information delivery service. We're trying to fold it into our culture, and it's working. We're starting to show and demonstrate to NASA and hopefully our water managers why we need to have an office that is there all the time, talking to water managers, as you see in the big cog there, and interfacing with NASA on what needs to be done, what missions need to be flown, what projects need to be focused on. And that's out at JPL right now. Sorry for my delivery there. Understanding the needs is a key component of that. And so we've done needs assessments in the Colorado River Basin, the Columbia, and now we're moving into the Rio, Missouri, and the Arkansas Red River basins. And these assessments are not only meant to understand the needs, obviously, but it's also to understand the users, those who need the data and why they need the data. And then it's to establish what can we do and what needs to be done. And so, you know, it could be that some of the needs NASA can't do anything about. Obviously, there's a lot of those, but what are those needs that we can provide some value to? So in making those connections over the years, and this evolves as we move along, as we obviously had drought as a major issue. So drought severity evaluation tool for the Navajo Nation and indicators for the state of Colorado was one where we're making these connections and building these solutions in agriculture, satellite irrigation management for California, and also the high resolution soil moisture products that are becoming more prevalent and providing those to USDA. Water use for the state of Mexico and beyond is also one of the things that is going to be a growing product and product line. So this transition, I'm going to check, make sure on track here. Oops. Okay. My apologies. Managing myself here. And one of the other issues is on the needs assessment is on the very other end, and we have projects, and then how do you sustain that? And one example is the Airborne Snow Observatory of understanding how do we transition this, and we took a lot of lumps. There's a lot of pain in this process, but we got there. So how do we replicate that more effectively in the future? How do we take NASA technologies, NASA developed tools, and get them into operation? And it could be in the commercial sector, it could be in a state agency, it could be in an NGO or another organization. Whatever that is, how do we do that? And how do we do that all the time? And I know the Western states really made a point of saying, NASA, you have to do better. And so we developed a series of workshops, and we're trying to schedule the next one that got hit with the pandemic now, our second one, where we're actually working with the federal agencies and the state agencies to understand how do we transition these technologies more effectively. We have a WAO dashboard trying to identify and target where we're doing work and how much work we're doing. I think one of the takeaways here in this is understanding that with water, obviously in the West, and you guys know this best, is there's a federal agency component, a big component to that. And how do we interface both with the end user and the federal agencies that may be interfacing with that, whether it's snow and USDA and NRCS, or reservoir management with USBR and the Army Corps, whatever that is. Are we making the right connections with the right organization to provide that information? Just some examples as I move to the ends of my discussion. We've developed a project with a lot of collaborators, whether it's federal agencies, USGS, USDA, other organizations, states, universities, EDF, to develop what's called an OpenET tool. So two of the things that we want to get out of this tool, one is provide easier access to evapotranspiration information that is usable for end users, whether it's state managers, whether it's local farming and management districts, and to make it more accessible and usable. And the other is also to do comparison, understand the differences between these evapotranspiration products, and be more conscious of the differences and what works better in other places might not work in this place. So bringing all this information and making it more accessible to end users. And this will be rolled out very soon. A website will be presented and opened up very soon. It actually got delayed a little bit because of the pandemic events and the delays that we've had. And so hopefully those of you that need this information will provide us a lot of great feedback. Evapotranspiration, the ET product, whether it's from Landsat or MODIS satellites or from other satellites that are coming online, we feel is a great value that the satellites can provide, and it's getting better and better. Providing the drought information, as I mentioned before, to communities that may not have great access to information. And the Navajo Nation right now is using this to help them with their allocation of funds. And this really builds out our need on outreach too, and training. Water quality. As I said before, it's really moving from the oceans now and really moving to a better use in the inland. Now, we can't detect if that bloom is harmful, but we can do a better job of providing information to states and the environmental departments on where there may be a harmful algal bloom, where the indicators or the conditions are right for a harmful algal bloom. And this is great science backing this up, and with our teammates at EPA and NOAA, really developed into a tool that's already being used, and we're continuing to develop the tool to transition it. And remember that operations to transition, or transition to operations issue, we're working at that right now, but it's already being used for decisions. I throw this one in here, and I won't talk about it very long, but I think the point we wanted to make here is really moving out on the groundwater information. I think GRACE provides us a great foundation of groundwater information, but it's coarse and it's missing a lot of the information that we need to make better decisions. And one way, one project at Stanford is helping us understand the geological structure underneath the ground, understand so that we can understand the flow of water a lot better. And I think that's one key missing element in our information and our models that can help improve the use of GRACE information. And stream flow. Up in Alaska, where stream flow is a big issue and where we don't have all the gauges that we would like to have, starting to understand how we can use satellite data to help improve that flow information. And USGS has been a great partner on this, and great to be up in the state of Alaska working on this issue. And just going back to the needs assessment, and I know I'm at my time, so I'll just close out a few slides on the needs assessments. This is also really a time for us to learn from one another about what the capabilities are and what the needs are, and interacting and understand who we need to interact with. One of the jobs of WAO is connecting end users with this broad breadth of NASA researchers, NASA technology, NASA information. So we might not, and oftentimes don't own it within WAO, but we may know the researcher who's funded by NASA that may be working on stream temperature or turbidity or evapotranspiration that's right for your instance. And that's what we try to, one of the big jobs of WAO is to connect those two. And then develop use cases and understanding how we can move forward. So if irrigation is a big issue, what can we do right now to develop it into a tool that you can use? And this came out of our Colorado River Basin Needs Assessment. And finally, the big thing, going back to the difference between basic research and what Western Water Applications Office is all about, and that is partnerships. That is the key difference between a basic research and applied research, really making a difference for our end users. Is we have to have that sustained, persistent, and interactive relationship with end users and a lot of different other players. It could be engineering firms, it could be retainer firms, it could be NGOs, whoever the players are, having those partnerships in place. And with that, I'm going to end up with just some points of contact and questions. So Forrest Melton, many of you know, Stephanie Granger and Indrani Grasic are our key points of contact for WAO. Thank you.
Thanks a lot, Brad. Now we're going to shift over and hear from Tim Newman at USGS.
Thank you. So Tim Stryker and I are going to work to pull the slides up. Hopefully Tim's able to pull them up. But yeah, are you able to, Tim?
Yeah, working on that right now.
Okay. So as he brings these up, I just wanted to thank you all for letting us come and chat with you today. My goal here is just to kind of give you a background on the National Land Imaging Program within USGS. We work very closely with NASA and NOAA and the other agencies that deal with Earth science and Earth observation. And so I want to give you an update on some of the different activities that we're embarked on, including some of the new products, the new Landsat-based products that have been released just over the past couple months. And there are some new ones even that will be coming out in the next month or two. So I wanted to kind of give you a heads up on those. I can't tell from my screen if Tim brought the slides up. Are you up?
I see it on mine, but perhaps others do not.
Yep, we see it, Tim.
Very good. So if we could move to slide 2. I just wanted to touch on the program components that we have. It's roughly about $100 million a year that comes to USGS through the Department of the Interior. And most of that money goes into the satellite operations component of the program. And of course, with satellite operations, that's all things Landsat. So we have 2 satellites in space, Landsat 7 and 8, and we're developing Landsat 9 with our NASA partner with a goal for launching next year in fiscal year 21. We also do user requirements, spend a lot of time, not within just USGS and Interior, but with all the federal civil agencies, gathering the user needs that people have for Earth observations. And then, of course, Brad mentioned that we're beginning to talk now about Landsat Next, which is a very exciting time in the program. We also have a significant science research and investigations project, a set of projects. And so we fund different science and applications across the country, focusing on things like drought monitoring and cropland estimates. We also work with unmanned aircraft systems, UAS, and we do some other types of R&D efforts working with our partners. And then finally, we have a classified component to the program, the National Civil Applications Center, and what we call the Civil Applications Committee, which is all the civil agencies that make use of classified systems to meet their civil needs. And so all of those are about bringing data to the public through both many different mechanisms and improving the investment that the taxpayers made in these very expensive satellites. Go to the next slide. So the next slide speaks to Landsat. And I'm sure most of you know Landsat and the history behind it. Certainly Western States has been a big user of Landsat over the years and has had an influence.
Yeah, sorry to interrupt, Tim. I'm not seeing the slide transitioning on my screen. So is it transitioning on others?
No.
Okay, let me try to reload this here. Sorry about that.
So I will just say that Landsat's been used throughout its 48-year history to track changes on the Earth's surface. And so there are many, many applications. Whenever you go to Eros in Sioux Falls, when you go to Earth Explorer and pull down a Landsat image, you generally have to register. And when you register, you specify what applications are you using the data for. Primarily, of course, it's land use, land cover change, agriculture, forestry, and ecosystems, and so forth. But there are many different applications. We call it the Swiss Army knife because there are so many different applications for Landsat. With the 2 satellites, we are collecting a large amount of imagery every day, equivalent to roughly North America and Europe every day. And so that's a lot of imagery, a lot of data coming into the center. But it's also highly calibrated data. So it's not just a pretty picture from space, it's science quality data that we use to tease out those long-term trends in climate change that are happening across the world. I don't know, Tim, where you're at with your charts.
I believe we're on the what is Landsat slide. Is that what everyone sees?
Great. So we can move on to the next one, Landsat users and applications. It is the most widely used land remote sensing data source within the federal civil agencies. Many users, federal agencies, states, local governments, foreign agencies, the general public. There are a lot of programs that rely on Landsat. I highlighted the Western States consumptive water use and a number of others. Many different applications, as I spoke to earlier. And so it is that also a reference for some of the small sat commercial companies out there. Planet uses it for calibration reference. And so heavily used out there in the community. Go to the next slide. The updated economic valuation of Landsat, a study was just done recently and published that came back with an estimate of $3.5 billion in benefits within the year 2017 for Landsat data and imagery. And so the US accounted for about 2 billion of those benefits. So a lot of folks are using it. A lot of people depend on Landsat for their businesses and for their economies, economic activities. And so that's a published report that just came out last year. If you go to the next slide, it talks about the status of all of our missions. I mentioned 7 and 8 are in orbit, operating today, collecting lots of imagery. We do expect that Landsat 7 will be decommissioned next year. Landsat 7 is running out of fuel. Of course, it launched back in 1999. So our hope is that Landsat 9 will actually launch prior to Landsat 7 running out of fuel. And we will, at that point for 7, we will decommission it, lower its orbit. But hopefully everything will work out, and Landsat 9, which is essentially a copy of Landsat 8, will go up in the 21 time period, probably summer of next year. We also have an extensive archive at AROS, as you know, at Earth Resources Observation and Science Center in Sioux Falls, South Dakota. 8 million plus Landsat scenes are available going back to the 70s, but also a lot of other data sets. So if you haven't been on Earth Explorer lately, you ought to jump on there, because there's a lot of different satellite imagery data sets, including ResourceSat-2, which we collect over the US, but also a number of others that are out there, and unmanned aircraft system data as well. Landsat Next, I'll just speak to briefly that we have had a number of studies over the past year or two. NASA is developing the technologies with their SLIT investment line, and we've been collecting the user needs. So it all kind of came together in an architecture study that was done over the past 18 months. The team delivered its report in January, and now the two agencies are working together to agree on what that architecture will look like going forward. So this is after Landsat 9. What is it that we want to do with this mission? So details will likely be announced at the time of the FY22 budget release, which will be February of next year. But there's also an expectation there will be more information that will be coming from the agencies over the next few months. So stand by to hear more on that. On the next slide, it speaks to the Landsat legacy. You can see the yellow, we are here. We're right after, it's in 2020.
Tim, this is Tim. I'm sorry to interrupt again, but I'm not advancing once again, so let me redo this. Sorry, everyone.
So, but just in speaking about Landsat and where we're headed, we see, again, partnership with NASA going forward. Our user needs have shown that the community really wants better spatial resolution and more spectral bands. So no big surprise there. And they like better revisit. So all of those can't be solved by one mission, can't be solved by Landsat by itself. But working with our partners in Europe, particularly the Sentinel-2 people, the Sentinel-2 program, there are ways with different investments to try to do better in terms of spectral, spatial, and temporal. So as I mentioned, the architecture study team finished its work, and we are now developing those options for the next budget cycle. When we get the slides back up, you can go to slide 8, Tim. We'll talk about science products. So most of the rest of the presentation is aimed at the science products that Landsat puts out, because we do spend a lot of money on these satellites, billion-dollar observatories. We really want to take the time to develop the kinds of products that the users want. They don't want generally just level 1 raw data that comes down. Obviously, raw data is not very useful. So we have processed it historically to something we call level 1, which is level terrain corrected data. That's the traditional Landsat scene that you see in the archive when you go pull up a Landsat image. But what we've done over the past couple of years is moved more toward level 2 and 3, meaning more processing. So we process that level 1 into a form that's easier for users to access and use every day in their applications. So
Okay,
level
sorry to interrupt again, Tim. I believe this is back up for everyone.
Okay, so this is slide 8. So there's a number of level 2 products that I have in that center circle there, and I'll walk through some of those with you just to kind of give you the background on those. And then level 3, even further processed. So you're really getting into information, information that folks need. You don't want to have to be a remote sensing scientist necessarily to break down these satellite images and use them. Everybody has needs when you look at surface water extent and others. So I'm just going to kind of walk through these over the next few charts to give you a sense of these products. First one out of the deck is Landsat surface temperature. And of course, for the last couple of Landsat missions, we've had a thermal instrument on board, or thermal bands. And so those bands are really important to determining what is the surface temperature. And then, of course, that leads you to evapotranspiration. So with temperature, you can then go ahead and calculate water consumption on the surface, and that's certainly something that the Western states have been doing for a long time. The new surface temperature product is actually a 30-meter product. Even though the instrument that collects surface temperature is 100-meter spatial resolution, we can downsample it and we can produce a product that users can utilize at 30 meters, at the 30-meter scale, as the other bands of Landsat are. So that product is out there. It's available. It's a little different. When you talk about surface temperature, that's not necessarily the same as what a stream gauge might measure, because a stream gauge is deeper in the water. But the surface temperature certainly can be used in hydrological modeling for that long-term temperature record, because it goes back to 1982, since we've been collecting the thermal data. So we have been spending some time working with the stream gauge folks to better understand how they might be able to utilize this data in their applications. I'll go to the next slide. Slide 10 is our Provisional Aquatic Reflectance product. This is a new product. It's provisional. When I say provisional, that means it's kind of in its test phase. And so what we want is lots of folks to go get it and pull it out and play with it and use it to give us some community feedback. How useful is it? Are there some changes you might suggest to it? So it's on demand. You can go in and you can order over the US, you can order these aquatic reflectance products. It is, again, a 30-meter product. You can pick out harmful algal blooms with a product like this. It is available through the website that you see at the bottom of the screen, the ESPA website, and also on the product webpage. But we think this is going to be very attractive to the inland water community, because you can use aquatic reflectance to generate higher level science products like chlorophyll, color dissolved organic matter, and turbidity, and so forth. And so one I would recommend you take a look at. The next slide is a fractional snow covered area. So again, it's taking advantage of Landsat's history. You can go back to 1984 with this product. You can go back at the 30-meter scale and look how the surface snow has changed throughout the Western United States, for example. You can go back and see year by year how that extent changes, the snow covered area, going back a number of years. We use this, we generated this product using our analysis ready data. So we have a whole construct within the archive where we've tried to process the data a little bit more to make it more useful. So today it's available for the Western United States and Alaska. So this isn't a global product, but it is available within those areas. Go to the next slide, 12. It speaks to dynamic surface water extent, similar to what you see with the snow cover. You can get changes of where the surface water is over the past years, from 1982 on, actually. So you can go back and you can see what's changed as far as the surface water extent goes. We can update this every time we get new imagery, so it kind of gives you a chance to see how the surface water is changing. It will provide information on surface water inundation, going back, like I said, to 82. And there are actually 6 products associated with this. So products like not only just is water there or isn't it there, but also you can see the condition of the water. So is it water, is it wetland, what's the confidence, and so forth. So these are all available within Earth Explorer. You can find it there. We're also looking to add Sentinel-2 data to this to increase the temporal frequency so that you'd have updates more frequently. The next product on 13 is a new evapotranspiration product that's just coming out, maybe as early as next week. We've been tracking this. This new product is our latest in terms of evapotranspiration, and it's based on an algorithm called SSE-BOP, which I have to admit I'm not familiar with, but it is a USGS developed simplified surface energy balance algorithm. And again, like a lot of these, what we expect is when we put this product out there, that people will come and get it and they'll find it and start hopefully using it in their applications. It is suitable for operational use and large scale monitoring, and we see it with about 85% or higher accuracy. The provisional period, though, for this product means we're validating that. Like, how accurate is it really across the country in different places? And so that's an aspect of each of these products. The next slide 14 is on LC map. That's a huge effort. It's level 3 data, land change monitoring, assessment, and projection. It's our way to go and monitor the entire record, assess the entire record, and project out into the future where we might see landscape change or land change in the future. So it's kind of an exciting new approach to what we're trying to do here. We want it to be very user-friendly. And so it's live, it's out there now. There are a number of products associated with LC Map, which I'll show you in a second. These have just been released over the past month. And so again, you can focus in on a certain area. This graphic, I don't know if Tim, if you can click the graphic to run the change on it, where it says 1985. You can actually step through the changes in Richland, Washington.
Yeah, it is actually running on my screen. I hope others can see that change as well.
Okay. But you can see how the land classification changes going back, and you can stop it at any point in time. You could take a look at policies that have been enacted over these areas in certain time periods, and then see how did the land change. How did the land use and land cover change as a result of policies that are enacted at that level? So it's really an interesting tool. And the best part of it, I think, still to come is the projection piece, where we could look out and say, over any area, given the 50 years of data that we've collected, here's where we see it going, obviously with some error bar attached to it, but where do we see the land change occurring in the future? So LC Map is moving us in that direction. If you go to slide 15, you can see the specific products that are part of LC Map. And again, these are all available online via Earth Explorer. And so it's not just land cover classification, but it also has land condition change and so forth. So again, I would recommend you take a look at some of these, and there may be something there that's interesting to you, and let us know what you think. The next slide, slide 16, speaks to what we call Harmonized Landsat Sentinel-2. This is actually a NASA activity that we've been tracking closely. Sentinel-2, you may know, is a satellite very similar to Landsat. It doesn't have thermal bands on it, but most of the other bands are very similar and better spatial resolution, actually, to 10 meters with their system. But what we found that users would like is better revisit. So with just Landsat, of course, you have a pass every 8 days, and clouds can get in the way. With Sentinel-2 and Landsat together, there's 2 Sentinels up and there's 2 Landsats. You can get that revisit down to less than 3 days anywhere on Earth. And so if you're able to use both Sentinel and Landsat for your applications, it gives you a tremendous advantage when it comes to that revisit. And so that's what this effort is all about. We're trying to compare these sensors to process in a similar way so that users can go back and forth between them and get the information they need. It's not trivial, but we're on track to, I believe we have all of North America covered now, and we're moving toward a global harmonized Landsat Sentinel-2 data product. These last few I'll move through quickly. 17 is the National Drought Monitoring. Of course, you've probably recognized the projects Veg Dry and Quick Dry. Those have been out for a long time. Veg Dry is a weekly national drought tool. It's been around since 2009. It does indicate levels of drought stress on vegetation at about a 1 kilometer spatial resolution. So it doesn't use Landsat, it uses MODIS, but that's an activity that we help fund with others. Quick Dry was built on the Veg Dry models. That's a quick drought response index. That's focused more on short timeframes, like short 1 month timeframes, to show the degree of environmental stress in any given area. So both of those tools are important and used by the drought community. This is just a general statement about Landsat and water monitoring. We know that evapotranspiration is a big, heavily used application across the West. I think nearly every Western state has adopted the model. I think that originally might have came from Idaho. In fact, that application won a Harvard University JFK School of Government Award a few years ago. But that is used heavily, and it is based on the Landsat thermal data that helps you with those calculations. But also I would say that Landsat's being used more and more, especially Landsat 8, which was a significant step up in quality from Landsat 7 as far as its signal to noise. So it can be used to detect and address harmful algal blooms in lakes and coastal waters. Now go to the slide 19. Fire mapping. Landsat's been a long-time contributor to multiple fire applications, including land fire, which is a joint USDA-USDI project or program. That really helps with fuel management, understanding what's going on as far as the fuel, what's been burned, and so forth. MTBS, monitoring trends in burn severity, tracks all fires greater than 1,000 acres or more in the Western United States and 500 acres or more in the Eastern United States. Again, a long-term program that uses Landsat as its basis. And then there's also BEAR teams, burned area emergency response teams, that are issued out after a fire's happened to assess any possible degradation in the land after the fire. So a lot of fire-related activity. Slide 20 speaks to the agriculture aspects, which certainly Brad Dorn knows really well, having come from USDA a long time ago. It was a long time ago, wasn't it, Brad? But USDA has been a heavy user of the Foreign Ag Service of Landsat to look at crop monitoring around the world. And so, again, this global scale that Landsat can provide is very useful. But again, our whole point is to try to not dump a lot of data on folks. It's to pull out the information into products that are easier to use and to generate. Slide 21, and I'm almost finished, speaks to invasive species mapping. Cheatgrass is a huge thing in the West, and you all know about it probably. When I first heard about cheatgrass, I had to hear it a few times to understand. So now what's the issue with cheatgrass? But it is very invasive, of course, and can spread and grow quickly. And then you have the fire. It burns very intensely, and it's spreading everywhere across the Western U.S. So I know that there's a working group that's been set up by the Western Governors Association to address cheatgrass. If you use Sentinel-2 and Landsat 8, you can get weekly estimates of vegetation greenness, which can help you capture invasive annual grass phenology, like when does it green up, at a spatial scale and frequency that are relevant to local land managers. And so that's another application that we've been highlighting lately. And it brings me to the last slide, slide 22. What is our program trying to do? Well, we have those 4 thrusts up in the upper left corner. We want to do better on our operational systems from Landsat 8 to Landsat 9 to Landsat Next. We want to meet more user needs across the community, across the Fed Civ and the state and local community out there. We do research, development, and innovation. If you see the blue stretches, the blue items there, we're looking more and more at hyperspectral technology. What can we do in that area? We want to expand our product and service usability, and that gets to a lot of the things I spoke to today in this presentation. We want to make the products more available, easier to use, so we get the bigger return on that huge taxpayer investment in a satellite. And then we also want to make sure we communicate with folks to both internationally and domestically so that they understand what it is we're trying to do and what's available for them to use. So that's the end of the slide set. I'm happy to answer any questions.
Great, thanks, Tim. So as Tim just said, we're moving into the questions portion of today's presentations. So again, you can either ask questions using the chat, or you can unmute your microphones and ask questions that way. No? No questions?
Well, I'll answer Tim's question. This is Brad Dorn. It was over 10 years now since I've been there to USDA. So it's.
I still picture you, Brad, sitting at USDA and having these meetings on future of land imaging and some of these other things. So it's hard for me still to see you as a NASA person.
I still talk to them and I go, us, you know, I say we. So anyway, looks like there's some questions.
Okay, Tony? Hang on. I can't seem to reach Tony. Tony, can you unmute yourself?
I think I might have just unmuted him, or no.
Let's see. Cancel. I'm not being able to.
I heard you when you were speaking earlier, but
Okay.
not now.
I can't seem to unmute him. He's not coming up in my list.
Try to unmute yourself.
Let me see.
Deb, can you hear me?
Write the question on a white sheet of paper and hold it up.
I can hear whoever was just asking. Here we go. Okay, can Tony type his question in the chat? And so we do have a couple of questions in the chat. There's a question, can we get a copy of the presentation slides? So this presentation is being recorded and it will be posted to Western States Water Council's website under WestFAST webinars.
And we can also make the actual slides available for those who had trouble tracking when we had some technical issues earlier. Okay.
Another question, is NASA USGS also using the AMERI flux and other similar data for spatially distributed forest ET estimates?
That sounds like a great question for Brad.
Yeah, no, I wish I had the answer. I don't know if Forrest Melton's online that might know this.
Yeah, I'll just say quickly, yes, the AmeriFlux data is being used currently by the OpenET project and USGS to conduct an evaluation of all of the satellite-based ET estimates. So that analysis is ongoing and includes data both from the AmeriFlux network as well as from similar eddy covariance data sets collected by USDA ARS and a number of university partners across the US.
Okay, great. Okay, here's Tony's question coming in through the chat. Brad, can you speak to the integration of multi-agency benefits in NASA budget justification documentation?
Only that it sounds like a really good thing, Tony. I'm afraid I don't have any knowledge of any specific documentation that you may be referring, but certainly, I'm afraid I just can't respond. Maybe there's something that Tim knows about with the Landsat budget stuff.
Okay.
So I think, Tony, generally Landsat is funded from, obviously from both NASA and USGS. So we have different committees on the Hill. So there is generally language that's consistent between Interiors Committee and Commerce, Justice, Science when it comes to Landsat. So I don't know if that gets at what you're asking specifically, but that's an example where generally we would receive language that said continue to work with NASA on the Landsat 9 development. And NASA's language would say continue to work with USGS on the Landsat 9. So there is joint language generally in that regard. So I don't know if that helps.
The other component of this you guys might be interested in is the federal agencies do have it's a 2-year cycle where the federal agencies can provide satellite needs to NASA. It's called Satellite Needs Working Group. A lot of Landsat is in that, but that gets covered in I think the bigger relationship that NASA has with USGS. But a good example is USDA came and said we really need higher resolution soil moisture observations. And so NISAR actually, and OMB, this went through the process, and OMB went and said, okay, NISAR, you're going to do this. So it is a process that all the federal agencies can provide through, and it's actually administered through OMB. So they can provide these needs. NASA, can say, no, we can't do that, or that's impossible, or private sector is doing that. So they respond. But then in these instances where we can respond and say, hey, yeah, we can do this. It'll cost this much. OMB says, okay, we move forward. So that's another process. I don't think that's exactly what you're looking at, but.
Yeah, I can see Tony's chat on the chat side. I would also say Satellite Needs Working Group that Brad just spoke to falls within the U.S. Group on Earth Observation, USGEO. And USGEO is basically all the Fed Civ agencies that meet on a monthly basis. And we compare notes as far as our Earth observation systems, applications, benefits. We have a lot of lessons learned between the agencies. And most importantly, OSTP and OMB are both they're in the room for all of these meetings. So they generally do push for more interagency cooperation in these matters. And so that's been a real strong voice over the past few years to make the agencies work a little more closely together when it comes to Earth observation.
Hey, Brad, this is Roger Gorky, and I'm not going to turn on my camera right now. So you talked about, and I think you talked about earlier about, let you guys know what needs there might be, or, how can whether it's another federal agency or a small community or medium community or just other water manager, how can they figure out what the capabilities are? Because a lot of times it seems like if you know, you know, but if you don't know, you don't know. So how might we, maybe it's through more outreach through WestFAST, or, to show the capabilities of what you've got, because this is, from the beginning, you've talked about WAYO and a lot of your capabilities saying, helping decision makers make more informed decisions. But if a decision maker doesn't know that there's more information, how can we better get it out to them without overwhelming them with acronyms and the usual stuff that we can overwhelm people with?
Well, yeah, I mean, it's a huge challenge, and WAYO's chosen, and Forrest Melton, who's the chief scientist of WAYO, if you didn't notice my last slide, is working this every day, and we've chosen a basin approach because we feel it's a nice interface with NASA capabilities and water needs. It isn't perfect because we know within a basin there's lots of diversity and differences of the information that is needed, but it helps us at least lay a foundation for the water area or the Western water framework. So, certainly that doesn't solve, if they don't know what they don't know, how do we present our information in such a way that it is more intuitive? I think OpenET is one way of doing that. I think what we're considering is also the idea of getting examples, getting case studies where people see, oh, that water management district or that farm, an irrigation manager, or that municipality is doing it and using this information. That seems to be the best way to communicate to other users, because you're right. NASA has a hard time with that. WAYO does a great job, but they're just a small element. But NASA as a whole, we come at it very awkwardly to end users. And so trying to do that, I think one of the challenges we have is communicating then those successes, those communities. If we have a great success, for instance, in vineyards, how do we get the other vineyards who are trying to manage their water engaged and seeing that this is a tool? So I don't know if Forrest has anything to add to that, or.
No, thanks for the question, Roger. We are continually working on trying to find ways to improve our outreach and communication strategy. If you have particular thoughts or recommendations, always happy to chat and always welcome advice and suggestions from our partners on WestFAST and any of our partners through the Western States Water Council.
Yeah, I can say within USGS, we have the same concerns about reaching users and with information that makes sense to them and it's available. We've talked recently about putting a catalog together that would be maybe easier to digest, to come into, to see what types of products are available. If you're interested in this application, maybe this product would be of interest to you. But it's a perennial challenge to try to get this information out to users like you so you can understand what is available.
Okay, let me just.
And Tim, I'll just add, WAYO is working on doing something very similar for NASA capabilities that we think would be relevant to management of water in the Western United States.
Okay. Let me just run through it looks like it's been responded to, but I just want to read it out loud. The question coming in was, are high resolution 10M spot type multispectral images also available through NASA USGS products? It looks like the response from USGS, I don't believe so. We did that for a while, but the contract stopped. Now we do provide resource sat data for over the US. And then there are historic spot data sets available at Earth Explorer.
Yeah, from time to time over the past few years, past decade or so, we have had arrangements where we've collected spot data over the US and made it available through Earth Explorer. That contract ended several years ago, but we do provide resource sat. Now, resource sat isn't 10 meter spatial resolution. I think it's more moderate resolution than 10. But we're always looking to see what does the user community want, and in some cases the higher res data is Sentinel-2 provides 10 meter resolution data now over the US. So you can get Sentinel-2 data, which is all bands of Landsat with the exception of the thermal. You can get that now free and open from their websites in Europe, or we actually have some of that data posted at Earth Explorer as well, so you can get it there.
Okay. Another question coming in from Tony Willardson. For Tim, can you talk more about the multi-component architecture of Landsat Next? Also, how do you maintain data continuity? Will Landsat Next require working state agency business practices given the new data?
So one thing I can say about continuity is continuity was really the foremost requirement going into the architecture study team and the effort that they had over the past 18 months. So continuity is very important. We all understand it, the need to continue it. I can't speak really now to the multi-component piece because it's a little too early yet, but we are looking at, I can tell you that we are looking at many different approaches to doing the Landsat mission. This wasn't a case of just looking at the way we did it last time and copying that. This was definitely much more of an energetic effort to look out across the commercial companies that provide Earth observation data to get new ideas and insights on how we might be more effective going forward. And so, but again, I can't really speak to what's in the architecture at this point. That will be coming out in the near term. As far as the states go, I think also the free and open data policy has been pretty much preeminent in these discussions. Now, there may potentially be partners in the commercial sector where we'd have to try to figure out, could there be a way for us to have some of the data be free and then some not free? So there have been some discussions about that, but it's still a little early when it comes to Landsat Next. Heck, I'm just excited that we're talking about Landsat Next before we launch Landsat 9. Generally in the history of this program, it tends to wait until the mission goes up and then everybody looks around and goes, what do we do now? In this case, NASA and USGS started this effort several years ago on what comes next. So I'm excited that we're at this position right now, and I think you'll all be pleased with the result when it does come out.
Great. Okay, another question coming in. Are you able to share about the status of SWISAR technology and potential for snow water equivalent measurements?
Hey, Forrest, don't leave. He's been working these.
Yeah, I have not come across SWISAR particular. I saw that question. I was just looking that up to see. Let's see if there are other questions, and I'll try to come back to that. Give me a moment to check on that. And then in terms of SMAP and forest canopy, certainly under dense vegetation canopy, that's going to affect the accuracy of some of the data products from SMAP. So they are working on techniques using a combination of the coarser resolution satellite data with hydrologic models to improve those estimates. But yes, certainly in really dense forest canopies, that's going to have an effect on the soil moisture estimates from a radar instrument.
One thing NASA does really well is we spark new energy around an issue, and I think that soil moisture issue with SMAP, even though we didn't have a perfect start to that mission, the microwave measurements and then the radar measurements that are now coming out of NISAR is really, I think it's going to continue to grow, and it's amazing what we've learned just by having SMAP up there about the technology and of course about soil moisture. Yes, definitely, vegetation is going to affect that measurement, but we also are working with and have worked with the Forest Service now on a couple different and more on the research side on how that can contribute to fire prediction, risk, and that sort of thing. So, yeah, we'll certainly keep working at it. I think one of the things, though, I think we're going to see a real elevated increase in our knowledge and use of the data. We have the soil moisture network that's getting a lot of the momentum in USDA. And we're working with them, and that then drills down to the state agencies. So.
I'll just add there to the SWISAR question. It looks like that was funded by ESTO as a demonstration capability and was proposed for addition as part of the SNOWX campaigns. So I think it was part of the suite of instruments that were being proposed for SNOWX, and having a little bit of trouble finding information on exactly where the status is of inclusion of SWISAR on SNOWX. And it's possible some of that was delayed due to COVID-19 this year. But
yeah, those of you involved in SNOWX and SNOW, this is how we really develop into what would be a fully fledged satellite mission. And So all these technologies and this ground and aerial research are being done now in the hopes that we can break into a dedicated mission on snow. And we have cryo missions, but they haven't really been tailored to what we need for freshwaters and snow water equivalent in the U.S. So yes, thanks for the feedback, and also keep that input, because us pushing that forward, if this is really useful and this information is useful, another thing WAIO can do is we can push that up, and we desperately need that type of feedback. So thank you.
Right. So that looks like the questions, unless anyone else has anything.
Well, I was just going to follow up with just what Brad just finished up with. It's Roger Gorky again from EPA. What would you, and I guess it's somewhat related to my last question, is what do you specifically need from us as other federal agencies that might either help you do your job better, or before it was getting the word out, but like water quality with us? I know you've worked significantly on the cyano issue, and that's been a great success, but you know, what might you need from some of the other feds that can help advance your work? And if there's states on, you know, what might that look like from a state perspective, if anybody wants to chime in on that?
Well, the Fed agencies, one thing in particular is we have a lot of research going on in the federal agencies, USGS and water, and all the federal and land management agencies and the EPA. So one of our questions, and one of the things actually the Western States Water Council directed us to do, is say, get together on how are you guys developing out this research and transitioning it to states, and it may be through commercialization or whatever. And so I think more of that between not just us in DC, it's with the agencies focused on Western management in the West. You know, what it's going, you know, what's NOAA working on forecasting, and how can we contribute to that, and you know, what can we work together on? And if there are things that, hey, NOAA needs to develop a capability on that NASA has, how do we get that communicated up through, you know, the states and through our agencies and organizations? Is it GEO through our Satellite Needs Working Group? Is it so understanding that? So I think that is the Fed agencies and the guys developing these research out on water issues in the West, getting together and collaborating on some of these issues would be a big help. Because remember, NASA doesn't have a water mandate. We don't have any mandate to make decisions or provide information on water. That goes through the the federal agencies, then of course mostly to the states or directly to the states. So having that collaboration at that federal level provides that ability. You know, reservoir monitoring. You know, what's the next step in reservoir monitoring and management? You know, how can we make sure we're synced up to whatever information that is? And we've gotten that feedback, but how can we kind of systematically get that into all of our research discussions? So that's one way. There's probably others, but I'd say that's a way we're focused, what we're focused on now.
Okay, I do have.
Oh, go ahead.
Okay, I was going to start another question, but if there's a continue on to this discussion.
Yeah, one point on that. I don't know if folks may have participated in the AQUI subcommittees, and AQUI got disbanded. And I think a lot of this coordination and synthesis happened through these subcommittees. We've lost that. And so that's one thing where we're trying to rebuild it, and, you know, groups like this, but the people are still at the table, I think, and trying to make things work, but the organizational support isn't there in my mind. So just a comment.
Thank you.
It's a good comment. I mean, I know sometimes those committees seem bureaucratic and, you know, what does OSTP need another committee on? What comes out of those committees does go to my bosses, the administrator level. They see that, and that's important, even if it's, you know, 1 minute of their 24-hour day. They see something about Western water issues, and it's, you know, this evapotranspiration is a big deal, and we've got to, you know. So those committees had, if nothing else, that was and when you lose that communication from the administration and those communities down through the agencies. And that's huge. It's tough for Tim and I to push up. And it doesn't happen unless there's a specific issue that they're interested in. And so yeah, that's a good point, and worth to, you know, making sure we make them know that we need those committees.
Okay, a question here about SMAP. Are the SMAP products able to get good moisture data under forest canopy?
Yeah, I think we answered that one. At forest, and maybe you didn't get to that, but it is a challenge under the forest canopy, but we are working at it. But there's certainly differences in the measurements depending upon vegetation cover.
Okay, thank you. Okay, I think that might be it. So if so, I guess that concludes our webinar today. I want to thank everyone for joining, and I want to especially thank Brad and Tim for their presentations and all the time you've put into this. Greatly appreciate it.
You're very welcome. Thanks for the opportunity.
Yeah.
Thank you, everybody.
Thank you. Have a great day.